Okay, so today we're going to look at electron configuration. So when you're in junior cert, you would have had to do some of this, and you would have drawn a lot of your diagrams of atoms, like what you see right here, which was called the Bohr structure. In Leaving Cert, you don't usually use the Bohr structure at all anymore. So we're going to go through that today. So when you were in junior cert, you were probably asked to draw out the diagram for potassium and show its electron configuration. You would have gone to the periodic table, looked at the atomic number and saw 19. And then you would have thought, okay, so the first shell holds, which is n equals 1, the very first shell here, holds 2 electrons. Then you would have learned that the next shell, n equals 2, holds 8 electrons, and so on. 8, 8, 8. 8 was the magic number that you couldn't go above, apart from the first one. We always knew that the first one held 2 only. Okay, so you would have drawn out listed the electron configuration like so. 2 in the first shell, 8 in the next shell, 8 in the next shell, and then 1. And you have seen that all of those 2, 8, 8, 1 added up to 19 because there's 19 electrons. Remember, if it's a neutral atom, the amount of protons, which is the atomic number, it should be balanced out by the same amount of electrons, which is this electron configuration right here. Okay, so let's just talk through what we knew already. In this example here, we have one energy level right here, a second one, a third one, and a fourth one. So if I was talking about like shells or orbits or energy levels, which is the preferred term, we'd say the first energy level, n equals 1. The second energy level, n equals 2. The third energy level, n equals 3, and so on. Okay? So that's still going to be carried through and carried forward into the next way of how we look at these things. So, in the Leaving Cert, we have energy levels, like orbits of how we used to call them, or shells maybe. And we also have sub-levels. And that's basically the new part that we're going to add on, okay? Sub-levels. Okay, so I've entered in a little picture there. This is also in your book. So we call them energy levels because the very first shell has the lowest energy amount. Okay, so they're filled up first, as we know, and we know that from junior cert as well. They fill up the smallest ones first, and then you move upwards, keep going until you've reached the amount of electrons that you need for that atom, and then you stop. So they still have n equals 1, n equals 2, n equals 3, n equals 4, like we had when we were drawing out our shells for the Bohr structure. But you see now, hopefully on this side, these are our sublevels. Okay? So the very first one, n equals 1, has one sublevel. N equals 2, okay, has 2 sublevels. N equals 3 has, we do them green, 1, 2, and you can see there's a little jump here, 3. So 3 sublevels. And then let's just point out the 4 ones. 1, 2, 3, 4. N equals 4 has 4 sublevels. Okay, now in the leave insert, the only sublevel that we usually go up to is 4s, but you can see that 3D is up here as well. So we are going to be using these sublevels that I'm circling now when we're doing our electron configurations. We don't really use 4p, 4d, 4f because we don't go up that far in the periodic table. It's the first 36 elements that we would usually go up to for leave insert. Okay, so now let's take a look at what each of these can hold in terms of electrons. So the very first one, the first shell, and the S sublevel. So S sublevels hold 2 electrons. Okay, there's your first note, 2. Okay, so you can imagine if I just fill in, those little arrows represent electrons, one going up, one going down, 2. Now let's go to the next one, second shell, the S sublevel. It can only hold 2, no matter what energy level it is, the S sublevel can only hold 2. The P sublevel, see how we have 3 of them, 3 little dashes here. Each one of these can hold 2. So it's 2, 2, 2. So the P sublevels hold 6 electrons. And I'm just going to write in brackets 2 each. Okay, because there's 3 of them. 1, 2, 3. It's broken up into 3 bits there. 3s, it's an S, so 2. P, there's 3 sublevels in P, so 2 each. In total 6. 4s, 2. 3d then is next, and you can see how many there is, 5 of them. Each one always holds 2. Okay, electrons usually come in pairs, so there's always going to be 2 of something. Okay. And it's going to write in the last note that your D sublevel holds 10 electrons, and again 2 each for each one. Okay, let's just take a look at what they look like if we were to draw them. Like say you're asked to draw, what's an S sublevel actually look like? So I'm going to draw an axis. No, actually I'm going to draw better than that. I'll try anyway. Okay. So an S sublevel is the shape of a sphere. Okay, that's all you have to draw. You have an axis, XY axis. You can go Y, X, and you can put in a Z if you want to give it that 3D effect, X, Y, Z. And there is your S sublevel. So it means that the 2 electrons are moving around. Let's just draw them in. Random little dots are moving around that electron cloud that's in the shape of a sphere. Now, if you were asked to draw a P sublevel, we again would do the axis. And I'm going to make sure to draw in my label them, so Y, X, Z. And I'm going to do each one a different color. So the P orbitals look like dumbbells. This is what a dumbbell looks like. Okay. So that's going to be called your PX orbital. So again, remember each one of the P orbitals holds 2. So we can imagine little 2 electrons going in there somewhere. And then we have another one on this axis. So you can imagine another little set of electrons going in there. And then we have another one. I'm trying to get a different color. I'll just go green. up here on the y-axis, the same shape, and you can imagine 2 more electrons there. So this is called PZ because it's on the z-axis, and PY because it's on the y-axis. But altogether that makes the 3p sublevel, and then we've 3 orbitals, px, py, pz, that make up all of them together. And you can see that I have 6 dots there in total, right? So that means that the p sublevel holds 6 electrons in total, and the s sublevel held 2. Now you don't need to draw the d sublevel, so s and p are the only 2 you need to know how to draw. Okay. Now let's take a look at doing some electron configurations. So before we move on, I want to go and introduce us to the Aufbau principle. AUFBAU principle. So this states when building up an electron configuration, I'm just going to say EC, of an atom in its ground state. So that means there's nothing added, there's no excitement of electrons, it's just in its neutral ground normal state. The electrons occupy the lowest available energy level. Okay, always the lowest first, just like in junior cert, you did the first shell, then the next shell, and then the next shell. There's one really important thing here. Now if I bring you back up here, we look at the energy levels. Remember, the energy is going upwards. The 4s is lower in energy than the 3d. That means the 4s sublevel will be filled before 3d. Okay, now that might be confusing because you think 1, 2, 3, 4. But sometimes there's a section where you're just going to have to go the 4s first and then fill in the 3d. And you're going to have to remember that off. So let's get straight into it. We're going to look at sulfur, atomic number 14 and mass number 28. Now, when you've done this before, you would have gone 2 in the first one, 8 in the next one, and 4 in the next one. 2, 8, 4 gives you 14. Okay. So the very first one that needs to be filled up is the very first energy level, and it's got a sublevel of S. And you should remember that the S sublevel holds 2 electrons. So you're going to put a small 2 up there. Now this number represents the amount of electrons in the sublevel. This represents the energy level. Okay, that number of electrons, and then this is the type of sublevel, so an S. Okay, so let's start that one again. 1s2. Now we have to move up to the next one. 2s2. Okay, so we've got 4 electrons in total at the moment. What's after 2s2? So the second energy level has 2 sublevels, S and P. P. How many can fit into P? 6. Let's double count now. 2 plus 2 plus 6 is 10. So we need 4 more. I'm going to go with 3s2 because I can't put 4 in there. And then the last one is 3p2. Double check. 2 plus 2 plus 6 plus 2 plus 2, 14, which is our atomic number. And when you go through these, you know, you are going 1 to, see how you can see we're going 1 to 2 to 2 to 3 to 3. That's usually how it goes apart from the 4s one. And you can see that it goes from S, SP, SP, and then it's going to be D after that. Okay, so let's do another one. And we're going to go with potassium, which has an atomic number of 19. So if you want to try that one first, give it a pause, and then you can play on to see what the solution is. Okay, so the first shell, first energy level, has an S sublevel, and it holds 2. Next energy level, first sublevel is S, and it holds 2. Next sublevel in the second energy level is 2p, it holds 6. And then we go 3s holds 2, 3p6. Now I've gone far enough, I just want to double check. So 2 plus 2 plus 6 is 10. 10 plus 2 is 12. 12 plus 6, 18. So we only have one left to go. And you remember, we're at 3p at the moment. So we've all that filled in. The next sub-level up is 4s, not 3d. It's 4s. And we only want one extra electron. Okay. I'm going to write another one for you. Argon, 18 and 40. So you can give that one a go. 1 in the first one. S holds 2. Second energy level. S holds 2. Second sub-level in the second energy level. P holds 6. Third energy level. S holds 2. How many more do we want? 3. P, 6. Okay. Last one for you. Calcium, 20, 40. 1, S, 2. 2, S, 2. 2, P6. 3s2, 3p6, and then hopefully we didn't do 3d2, we went 4s2. Okay, remember the 4s has a lower energy state than the 3d, so it's going to be filled in first. Great. Now we have 2 special cases that we need to be aware of. So the 2 special atoms are chromium and copper. So whenever you're asked to do chromium or copper, there's 2 things that you remember. I have to really pay attention here and make sure I don't mess it up. Okay, so let's take a look at them. Chromium. If I was to fill it out, what is the actual atomic number for chromium? Okay, it's 24. So you might think, okay, all right, I'll do this. 1s2, 2s2, 2p6. Yeah, which seems perfectly fine. But it's not, and that's not what happens. What actually happens is that you see how this fella and all of the previous ones are completely full to the brim. So that means they're really stable. Okay, all of the sublevel is completely full of electrons. There's no partially filled sublevels at all. Now 3D has 5 sublevels, okay? And at the moment, it's only got 4 electrons in it. So we've got electron here, 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 and here. And it really wants to fill up that one. It's really unstable because it's not even half full. So what it does, within the atom itself, it's going to move around the electrons to gain that extra stability that it needs. So to do that, it goes back down to the 4s sublevel and takes one of the electrons. So the actual electron configuration looks like this. Everything else stays normal, but it's taken one of the electrons in the s sublevel, so that becomes 4s1 because an electron is gone, and this becomes 3d5. Okay, so you can see 1, 2, 3, 4, 5 electrons filled into each of these little compartments. So that means that's half full now, and this is also half full. So the 4s and the 3d are now half full, which gives the atom extra stability rather than having one full and one nearly there. They both rather to be half full than to be in that configuration. So the proper one, let me just write it up again. 3p6, 4s1, 3d5. Now I just want to write down a few notes on that for you, so you can put this into your copybook if you want. A full, okay, so that note just says a full or half full sublevel is much more stable than a partially full sublevel. So 3d4 would be partially full, and it's so close to being half filled that it just moves the electrons around to gain that extra stability. Okay, so we're going to move on and we're going to do the copper, which is 29. Now, so you can see that this is, if you want to do it out, you might see that, oh, it's very close to being a full D sublevel, and see if you can manipulate the electrons around to see what it's going to be like. You might be tempted to do this, which is the old way: 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. But again, see how that's so close to being 3d10. So at the moment it's got 1, 2, 3, 4, 5, 6, 7, 8, and then 1. It's lacking that extra electron it needs to get to a full sublevel. So it's going to much rather have this 4 S2 sublevel be half full, and for 3D, the 3D sublevel to be full, completely full. So the actual configuration looks like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. I'm just going to wipe that out. And 3d10. So half filled here in the 4s1 and fully filled here in the 3D10. So an increase in stability. Now that might be hard to remember, but if you just remember chromium and copper, and that there's never a 3D4 and there's never a 3D9.